Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. The previous lesson focused on DHCP, NTP, and high availability. This lesson will deal with Enhanced Interior Gateway Routing Protocol, EIGRP. Let us begin with the objectives of this lesson. By the end of this lesson, you will be able to describe EIGRP's metrics and administrative distance, describe how EIGRP's topology and routing table are created, including dual. Describe automatic and manual summarization. Describe neighbor requirements. Configure EIGRP for IPv6. Let us discuss EIGRP in the next slide. Enhanced Interior Gateway Routing Protocol, EIGRP, is a proprietary Cisco protocol. It replaced Interior Gateway Routing Protocol, IGRP. EIGRP is an advanced distance vector routing protocol, but it is also called a hybrid. It does not have a total view of the network as a link state protocol would. EIGRP does not require a hierarchical addressing scheme, but it works better with it. EIGRP is the only routing protocol covered in this course that can support non-IP protocols. Protocol-dependent modules, PDMs, handle Novell IPX, AppleTalk, as well as IP. Convergence occurs rapidly. A network needs to converge or settle down to normal operations after a change. For example, if a router interface fails, many events occur. The router recognizes that there is a failure. The neighbor or neighbors on the other side of the link recognize that there is a failure. The router and its neighbor must recalculate the routes for their routing tables since any routes using the interface no longer work. These are just a few of the processes that occur after a change in topology. The time taken for the completion of these processes is called convergence time. Let us discuss tables in the next slide. EIGRP maintains information in three different tables. The first is the neighbor table. To exchange routing updates, routers must become neighbors. EIGRP maintains information about these neighbors in the neighbor table. The second table is the topology database. A router stores the routing information it receives from its neighbors in the topology database. The dual algorithm is run against this topology database to determine the best route for each destination, which is offered to the IP routing table. The third table is the routing table. This is the IP routing table, shown with the show IP route command. Now we will discuss how routers become neighbors in the next slide. Neighbors are routers that exchange routing updates. They must meet certain conditions. Either neighbors are discovered automatically through RTP hello messages, or they are statically configured using the command given on the screen. Let us look at the working of hello messages. Hello messages are sent at certain intervals to keep in touch with the neighbor and check if the link is up. The hello interval defaults to 5 seconds. If a neighbor does not receive a hello message in the specified hold time, it assumes the link is down and neighborship ends. The default hold time is 3 times the hello interval. The default values can be modified with the commands shown on the screen. In the next slide, we will discuss the conditions required to establish neighbors. Remember, to become neighbors, routers must meet certain conditions. The addresses of connected interfaces on both sides of the link are in the same subnet. The routers have the same Autonomous System Number, ASN, a number that indicates the routing process. The connected interface is not configured as passive. If authentication is enabled, the type and password match. Additionally, key values must match as it determines which information is used to construct the metric. When a router acquires a neighbor, the following type of message appears. Neighbor 10.1.23.2 Fast Ethernet 01 is up, new adjacency. We will now move on to metric in the next slide. The metric is used by Diffusing update algorithm, dual, to determine the best route. A lower metric is better. The EIGRP default metric uses the default bandwidth and delay on an interface. Depending upon the K values, metric weights configured, router load and reliability also influence the metric. Bandwidth and delay are for a specific interface, but load and reliability are for the entire router. Use the Show Interface command to display the values of these measures for an interface. Take a moment to review the output given on the slide. Let us continue our discussion on metric in the next slide. The interface defaults for bandwidth and delay are as displayed on the table. In this table, for each interface default, bandwidth and delay values are provided. Bandwidth is given in kbps and delay in microseconds per tens of microseconds. Take some time to go through this table. Let us look into bandwidth command in the next slide. Since bandwidth is used in calculating the metric, Cisco recommends that you set the bandwidth for serial interfaces as shown on the slide. Let us move on to delay command in the next slide. Using the delay command defines the delay on the interface in tens of microseconds. However, delay is displayed in microseconds for the commands shown on the slide. In the next slide, let us discuss routing updates. Routing updates are non-periodic, partial, and bounded. Let us see what that means. Neighbors exchange full topology updates only when a router comes up. Thereafter, only partial updates are sent. These contain information only on routes whose status or metric components have changed. There are no periodic updates as in Routing Information Protocol, RIP. Updates are sent only when there is a change, while in RIP routing, information is exchanged every 30 seconds whether any change has occurred or not. In EIGRP, updates are sent only when there is a topology change. The routing updates received are entered in the topology database. Let us look into diffusing update algorithm in the next slide. All routing protocols use some type of algorithm to determine the best path to each destination. What is considered the best path depends on the metric used as well as the algorithm. The algorithm used in EIGRP is Dual, developed by Dijkstra. Dual is run against the topology database to determine the best path and to rank backups for the path. Dual finds loop-free routes. The Dual Finite State Machine, FSM, selects the least cost path to insert into the routing table. After routers boot and initialize EIGRP, Dual is rerun only against those portions of the routing domain that are affected by a routing update. This is why it is said updates are bounded. Let us discuss topology database in the next slide. The following concepts are necessary to understand the topology database. Reported distance, RD, also called advertised distance, AD, is the metric between the next hop router and the destination. RD is used as the acronym here for both reported distance and advertised distance, to not confuse it with administrative distance. The feasible distance, FD, is the RD added to the metric between this router and the next hop router to yield the metric for the entire route. A successor, also called current successor, is the next hop router on the specific route. Let us calculate the feasible distance with respect to the above discussed concepts in the next slide.